Karibu mpendwa mtazamaji na msikilizaji katika programu yetu ya card series. Uh, my name is Humphrey Alex, and today I'm gonna share FEA software that we are going to simulate a wave propagation in a pipe, and we are going to use ABAQUS software. This is FEA software like ANSYS, like console, and we are going to propagate the wave. And we'll see the analysis and the results. So this is my window, and I'm going to open ABAQUS from command prompt. So click open button, window button, type CMD, type ABAQUS CAE, click enter, wait for ABAQUS to open, and then click OK. So this is a user interface. This is the interface for ABAQUS. Like in any other softwares, designing softwares, simulation softwares, we'll be having a toolbar, designing tree. But in ABAQUS, we have two kinds of toolbars. These toolbars are constant; they're not changing. But this toolbar is dynamic. It depends on the module. So if I'll open here, we'll have different module. This is nothing but FA steps. In FA steps, we have pre-processing, post-processing. We have pre-processing, assembly, and the post-processing. So we need to create a geometry, we need to define material, then we need to run our simulation, apply a load, boundary condition. So let's start. We are going to create a part. This is part. I'm going to choose rename it as pipe 600 mm diameter, and I'm working on 3D. And this is the working space. Mind you guys, ABAQUS, it has no unit. So you need to maintain unit from the beginning. So as of now, I'll be using meter as my unit. And since my pipe is 0.6 meter diameter, so I can select 1 meter be my working space. Working space means this area. This is my working space. Click continue. And then the toolbar with different lines like in SolidWorks or AutoCAD, we'll be having line, point, rectangle. So I'm going to select circle. Here you can decide either to select direct point from here, or you can use coordinate. We have this command line. It will be pop up to show us pick the center point. The center point is origin, so I can keep it 0, 0, enter. So our cycle will start from the origin. Then I can decide to fill here, select again this origin, fill here. Then you have to assign dimension to this. Our pipe, it has 3 mm thickness. So go to my dimension, give it 0.3 radius, enter, select again the inner cycle, it will be 0.297, enter. So we need to extrude. Since we're working on 3D, we need to extrude, and our extrude length, it will be 0.1 meter. Okay, cancel procedure. We need to extrude. So extrude, it will ask you. It depends. If you want to keep as 0.5 meters, as your choice. But I'm keeping 0.1 meter. Then click OK. This is my pipe. So now I need to create partition. So partition, guys, in some geometries, it will be well defined. I don't need to create partition. But for this, after sometimes I will need to do meshing. So I need to have uniform mesh. So for the pipe or for the circle shape, I need to do partition. So in a geometry that can be well defined and to get structured mesh. See, for example, if I go to mesh here, it will be yellow. To be yellow. But if my geometry could be a rectangle, then this it was supposed to be green, because a rectangle is a well-defined shape. So see if I'll say, let's say 1.5 millimeter as my mesh size, click apply, then okay, mesh, mesh part. So it will be meshing. So I was saying we can have here, we have brick element. In this surface, we have brick element. Even this, we have brick element. But see, this is not uniform. These elements are not uniform like others bricks element. So we need to do partition so as we can get a uniform mesh. Here, we don't have uniform mesh. If we come here, we don't have uniform mesh. So what I'm gonna do, delete mesh. Okay. Then we have to go to part. We are doing partition using datum plane. So I have to create a datum plane. Datum plane YZ. Click enter from the region, XZ from the region. Then it's gonna be like this. These are the datum plane. So we are going to do partition using these planes. Then partition here using datum plane. Here it will be asking you what to do, what the next step. Select datum plane. I'm selecting this, create partition, and then select the cell that you want to partition, select the hood geometry, click done, select datum plane, create partition, then done. We can see now we have this partition line, we have this one, we have four sections now. We have this one, we have this one, third one, and the fourth one. So part has been created. Now we need to assign material. Go to property, here at the module, go to property. No, not assembly, property. Assign material, you can rename it. Our material is made steel pipe. And mind you guys, whenever you're renaming in ABAQUS, make sure you're using underscore to separate between words. Otherwise, you don't need to leave space. So to give a well-defined name, I'm just using underscore. General, give it density. As I told you before, ABAQUS, it has no unit. So if you decided to use meter as your unit, make sure you are keeping throughout your modeling. So here, this is kilogram per meter cube. The density is 7850 kilogram per meter cube. And then mechanical property, elastic, Young modulus, it is 210 gigapascal. And Poisson ratio 0.3. Say okay. So now I have defined my material. Then I have to create section. Create section, homogeneous, section 1, you can rename it, but I will leave as it is. Continue. Since I assigned material before, so here material, it shows like mid steel. Click OK. Then assign section. It will be asking you which section you want to assign, but make sure you uncheck this because you don't need this. We don't need to create set as of now. So we can uncheck, select the whole geometry, click done. Section has been assigned. You will see the color change in this geometry. Okay, so the color has changed. Now we have created a section. So go to assembly, create instant. Make sure here it is independent because if you will make this dependent, if you want to edit mesh, it won't accept. So make sure this is independent. Independent pipe, this geometry has been selected. Click OK. Now we can step. Step is nothing but the time because we are propagating wave. So we are giving the time of wave propagation. Go to step manager, create, choose dynamic explicit, continue, keep it off, time period. I'm giving it as 4 e minus 4. This is seconds. Increment, you can decide to use either automatic or fixed. If I'll keep fixed, then I have to use user-defined time increment. I'm giving 1 e minus 7. Say okay. Dismiss. Then come to mesh. Now it is green, so if I mesh this, my meshing will be uniform throughout the geometry. So click here, select mesh. My mesh is 0.15 millimeter. Then click apply. The preview will be here. Then I say okay. If let's say I'm keeping 1, then click apply. We'll see the mesh distance, the element distance. So the fine mesh, the more number of elements. So keep it -3. Apply. Okay. So assign element type. Select the geometry. Keep explicit. Here, this is element type. We have C3D ATR. Quantum that is the deformable body. We are working on 3D and 8 node residual. Yeah, it has been defined here. We are using brick elements. So say okay. Now we can do mesh. Yes, it will take some time. So it depends on the process of your system. Some process it may take time. So now we can see throughout our geometry, it is brick element. So it is uniform. Okay. Now we need to create set. Set, this is the point that we will be applying our load. So go here, create set. I'm using 2 probes, which one will be transmitter and the second one will be receiver. So set one, it will be transmission point. I'm using nodes, so transmitters TX. Since I've selected nodes, then I have to select where do I need to excite. Keep in this way. Then I'm selecting these nodes. See, it has been selected. So I will be applying load throughout this region, and the wave will be propagating in both directions. The wave it is circumferential, so it will be tangential to this pipe in this way, in this way. Click done, and then I have to create set for receiving point. Set create node. For transmitter, I just need only 1 point. I don't need to have number of point, but I need to have only single node. So I'm receiving at this point, so I can select any nodes. Let's select any nodes at the middle. Say this node, this is my receiving point. Then click done. Okay, now I have to apply load. These are the boundary conditions. So this I'm applying wave in a circumferential direction, and the SH wave, the principle for SH wave, the wave propagation should be perpendicular or should be orthogonal to the load application. So I'll be applying load in Z direction, and my wave propagation will be circumferential in this direction. So when applying load, I'll be giving the magnitude is 0 in X and Y direction, and I'll be giving the magnitude in Z direction. Go create concentrated load, continue. Where do I want to apply load? See, here there are these points, but the point of excitation is this. Mind you guys, I created set before, so I'll name it as TX. So this set 2 is receiver. Continue. CF1 is X direction, I'm giving it 0. I'm giving 0 in Y direction, but I'm giving this magnitude as 1. And amplitude, this is in the instantaneous, but I have created a data set using MATLAB. So I'll select this. You can have multiple options, but I'm selecting tabular. I'm creating amplitude using tabular. Click continue. Then the table will come like this. We have frequency and we have amplitude. So I have selected, I created my data set in MATLAB. So let us open MATLAB, guys. You can click like this. So B is my frequency. I'm going to copy it and paste it here. And source is my amplitude. I'm going to copy and paste it here. Click OK. And close this. And maximize it again. So now, if I select this, I have created amplitude 1. Say OK. So now you can see this is the point where I'm applying load. It will be in Z direction. So I can dismiss. Yeah. After creating load, I have to define some post processing, which is field output and history output. So create here, edit, give it 100. And my area of interest is displacement. I don't need this for, so you can uncheck this. Strain, stresses, and I'm interested in U. This is my displacement. Say okay. Again, in my history output, my receiving point is the history output. So I'm getting the data from receiver. So I have set, this is transmitter, and set to, I didn't rename it. So this is receiver. Give the increment after every n increment, giving it 1. And again, my focus is displacement. And since I'm applying load in Z direction, that means I'll be having displacement in Z direction. So here U1 is X direction, U2 is Y direction, U3 is Z direction. So selecting this, clicking OK. Now guys, we are ready to submit our work. So job manager, you have to create job. So click create. You can rename it job. You can say pipe tutorial 1. Click continue. And here you can keep, depending on the capacity of your system, using multiprocessor, you have to take it. So some high performance systems, they're using even 16 processors, but I'm gonna use 8, or let's say 6. Here, the number of domains should be the same. So here you can keep 6, say okay. So our job is ready. And here you can see name, type tutorial 1, model 1, type is full analysis, status is none because you haven't submitted. So before submitting, we have to cross-check if there is any error or there is any mistake we have done. So you can start with data check. So here just click data check, say okay, and let it to run for some times. Yeah, it depends. It may take time, depend on the processor of your system. But if it is high performance, then it can take just a few minutes. And guys, here we do have this. We have this window. So this window will be showing whatsoever command you have done. It will be shown every command. Like we assigned the global seeds have been assigned. There are this number of elements have been generated. So the job input file pipe tutorial 1 has been submitted for analysis. So if there is an error, it will pop up here. So I'm keeping this so as you can view it well. Let us wait for sometimes. Here you can monitor. If you want to cancel the process, you can kill, dismiss, delete, rename. You can rename the job. So this is finite element software. Let us wait for sometimes. So sometimes you can try to monitor. Here you can try if we will submit, then our results will be shown here. But let us wait for sometimes.